Welcome back again to Advanced Functions, MHF4U1. This is another Trigonometric Functions chapter. In this lesson number 2, we are going to talk about radian measures and angles on a Cartesian plane. So we're going to also explore what is the radian measures between 0 to 2 pi. So this is a review from previous lessons, trigonometric ratios. So trigonometric ratios are defined by SOHCAHTOA. Sine, so, SOHCAHTOA. So sine represents opposite over hypotenuse. Cosine represents adjacent over hypotenuse. And tangent represents opposite over adjacent. Now, the crucial thing about SOHCAHTOA is that you need to ask yourself, where is your starting angle? So in this case, your starting angle is over here, the theta. Now, keep in mind, your theta cannot be 90 degrees. So it could be either here or it could be here. Okay, so depending on where your starting angle is, your adjacent and opposite sides can be different. So let's say my angle is here. So then a side that is opposite from this angle, which is over here, this is the opposite. And remember, the side that is the opposite from 90 degree is always going to be the longest length, which is hypotenuse. And lastly, the side that is right beside the angle is the adjacent side. So you may wonder, there are two sides that are touching the angle. Well, you have to keep in mind, the other side will always be hypotenuse, which is the longest length, and then the remaining will be adjacent. So it will be pretty beneficial if you were to label where your starting angle is, and then start labeling opposite, hypotenuse, and lastly the adjacent side. Now, when the question involves something like find the exact angle or find the exact answer, that means it involves a special triangle. Okay, so no decimal points. So to find, there are two special triangles that I want you to memorize. First, think of an equilateral triangle over here. So the equilateral triangle in this case is 2, 2, and 2. So what I'm going to do is actually I'm going to cut it in half. Okay, so if I cut it in half, this is going to be 90 degrees. Now, equilateral triangle, all three angles are equal. So you're going to do 180 divided by 3 sides. So this is going to be 60, 60, and 60. But because I cut it in half, this 60 now becomes 30. So if I have to draw the cutout angle, this is 90, this is 60, and the top angle is now it's going to become 30. Because it's cut it in half. So this hypotenuse stays the same too. And the bottom length, because I cut it in half, is now going to be 1. And when you do Pythagorean theorem with 2 and 1, this side is going to be square root 3. Okay. So the special triangle that involves the first one, it involves 30 degrees and 60 degrees. And 90. Okay. Now next is you are going to think of a isosceles triangle. So in this case, 90 degree. And the isosceles triangle is going to be 1 and 1. Now, if these two angles are the same, that means you're going to do 90 divided by 2, which is 45 degrees. And 45 degrees. Okay, I forgot the angle. So it makes sense. If the angles are the same, that means the length is going to be same. They're proportional. isosceles. And using Pythagorean theorem, this length, the hypotenuse, is going to be square root 2. So another special triangle, it involves 45 degrees. Now, keep in mind, this is a radian unit. So I want you to be comfortable how to go from angle to radians, or radians to angle. There's a conversion factor, 180 over pi. This you multiply if you are trying to figure out the angle. Your ultimate goal is to find the angle in degree. But if you are trying to find it in radian, that means you're going to flip it. The radian, the pi, has to be at the top, and the degree has to be at the bottom, so that if you were to have a degree, it cancels out. So your final answer, if you were to multiply this, it's going to be in radian. So in this case, so for example, if I have 30 degrees times, in radian, it's going to be pi over 180. So degree and degree cancels out, so you get 30 pi over 180. But 30 divided by 180 is going to give me 6. So it's going to be pi over 6. Now, but it's important to just pretty much have it memorized and it's in front of you right away. So 30 degrees in radian is going to be pi over 6. 60 degree is going to be pi over 3. And 45 degree is going to be pi over 4. So keep that in mind when we are working with radian with exact numbers. Okay, so another thing is Cartesian plane. So this is a Cartesian plane. When we're working with angle in degrees or radian, so let's write down the degrees. So this is 0 degrees or 0 radian. Here over it's going to be 90 degree. So 90 degree in radian is going to be pi over 2. How do I do that? Well, all you need to do is 90 times pi over 180. Now 180 degree is going to be pi. 270 degree is going to be 3 pi over 2, which makes sense, which is 1.5. And if it's 360 degree, we're going to say 2 pi. Okay. So 1 revolution is equal to 2 pi. Or you can see pi is equal to 180 degrees. And for Cartesian plane, there is a acronym that you have to remember. It's called CAST. C-A-S-T. So CAST tells you which SOHCAHTOA is going to be positive. So in this case, A stands for all of them. So SOHCAHTOA, the ratio in this quadrant, is going to be all positive. But on the other hand, in quadrant 2, S means sine. So only sine in this quadrant over here is going to give me positive ratio. On the other hand, in quadrant 3, tangent is the only ratio that is going to give me positive. And in quadrant 4, cosine is the only ratio that it's going to give me positive answer. So what does that mean? Sine and tangent in quadrant 4, where there's C, is going to give me a negative answer. Okay, so this is useful when you're looking for the exact answer, considering the sign of the ratio using CAST. Now let's just do a quick review of special triangles. So as you can see, this is the 30-60 triangle. And the length is 1, 2, and root 3. And this is the 45 angle triangle, which is 1, 1, the isosceles triangle, and square root 2. So please have this memorized and be able to draw it right away as soon as you see the word in the question, exact angle or exact ratio. Okay, so let's do a quick review. So use the special triangles to find the values of the trigonometric ratio. So in the question, there are two angles that are shown simultaneously. So remember 45 is pi over 4, 30 degree is pi over 6, and 60 degree is pi over 3. Again, keep in mind, to go from degree to radian, you're going to multiply by pi over 180 degrees. But on the other hand, if I'm going from radian to degree, then you're going to multiply by 180 over pi. Okay? So let's draw the special triangles. So I'm going to draw it. So let's practice again. So this is 60, 30 degrees. This is 2, 1, square root 3. And for this one, this is going to be 45, 45. And it's going to be 1, 1, isosceles triangle, and square root 2. So for this one, it says sine pi over 4, meaning over this one, 45 degrees. Sine, we said it's going to be opposite over hypotenuse. So in this case, opposite, let's say my 45 angle could be here. Opposite 1 over square root 2. So 1 over square root 2. But we don't like radical in the denominator, so you're going to rationalize it by multiplying by square root 2. Multiply by square root 2. The reason is because we don't want to have radical in the denominator. So therefore, square root 2 cancels out to become 2, and it becomes square root 2. So that will be your final answer when you are evaluating sine pi over 4. Okay, next, cosine pi over 6. Pi over 6 is 30 degrees. So this is my starting angle. And cosine is adjacent over hypotenuse. So from my starting angle, adjacent is over here. And hypotenuse is 2, the longest length that is opposite from 90 degree. So that means it's going to be 3 square root 3 over 2. And now I don't have to rationalize it because 2 is a whole number in the denominator. Next, tangent pi over 3. So my starting angle, pi over 3 is 60. So this is going to be my starting angle, 60 degrees. And for tangent, we know the formula is going to be opposite over adjacent. So from here, opposite is now this square root 3. Okay, so as you can see, depending on where your starting angle is, your length is going to change. So it's going to be opposite over adjacent. So this is 1. So therefore, it's going to be square root 3 over 1, which simply it means square root 3. Next, so another concept, what if I were to give you a point? Now consider a circle with a radius r. Now, and the angle alpha is in a standard position. So standard position means it's always in from initial arm over here on the x-axis to the terminal arm. So it's always within the 0 to 90 degrees. So that will be in standard position. And then the intersection between the terminal arm of the angle and the circle is noted by the point PXY. Now, so for example, if I were to give you a point for, in this case, this is, let's say, 3 and let's say 8. So I will be making a triangle from here, and always remember the starting angle is from where your initial arm is. So this is going to be my theta. And then 3 represents x value, so this length is 3. 8 represents the y value. And to find the radius, well, you have to use a Pythagorean theorem. And from there, you'll be able to find sine, cosine, and tangent ratio. Find the value of sine, cosine, and tangent function. Okay, so again, we're given a point, 3, 5. So 3 is going to be x, and y is going to be 5. I'm going to draw a separate triangle. So this, if I have to draw, it's going to look something like this with a 90 degree. But for simplicity, let's draw it again. So this is my theta or alpha, doesn't matter. And x is the horizontal, which is 3, and y is the vertical. Now to find this, the hypotenuse, again, we have to use Pythagorean theorem. In this case, it's going to be 3 squared plus 5 squared is equal to h squared. And then 3 squared is 9, 5 squared is 25, it adds up to 34, h squared. Therefore, h is going to be the hypotenuse, is going to be square root 34. I'm just going to keep it exact rather than decimal. Okay, so now that you've figured out all the components, let's figure out the sine, cosine, and tangent ratio. So sine, in this case, let's say theta, is equal to opposite over hypotenuse. So in this case, is going to be 5 over square root 34. And we don't like the radical in the denominator, so we're going to rationalize by multiplying top and bottom with square root 34. So it becomes 5 square root 34 over 34. Now let's do the next one. So cosine. Cosine theta is going to be adjacent over hypotenuse. So in this case, adjacent from this theta is 3. So 3 over square root 34. Again, same thing, you're going to rationalize it. So 3 square root 34 over 34. And lastly, tangent is going to be theta opposite over adjacent. So opposite in this case is 5 and adjacent is 3. So it's going to be 5 over 3. And that will be your final answer. Okay, another one. So this is a little bit different now. So this is still in standard position, y from the initial arm of x-axis. But the point is in quadrant 2. So again, we're going to make a triangle. And make a right angle triangle. Now let's label x and y. So this is x and y. And theta, it's not over here. It's always from the x-axis. Your related acute, which I'm going to talk about, it's always reference to the horizontal line of x-axis. So that is going to be theta. So in this case, theta is over here. And the bottom is going to be -3. And y is 4. Okay, so now to find the hypotenuse, we're going to do Pythagorean theorem. So when you do Pythagorean theorem, by the perfect square, the 3 sum is going to be 5. Okay, now keep in mind, x and y could be negative, but the radius will always have to be positive number because the distance can never be negative. Okay, but in reference to the location of x and y, it could be negative depending on whether it's in quadrant 1, 2, 3, or 4. Again, so we're going to write sine theta is equal to opposite over hypotenuse. So in this case, opposite is going to be 4 and hypotenuse is 5. So 4 over 5. Cosine, on the other hand, is adjacent over hypotenuse. So in this case, from my starting angle, adjacent is negative 3 over 5. So negative 3 over 5. And tangent is opposite over adjacent, meaning it's going to be 4 over negative 3. Now you will notice that only sine is positive and cosine and tangent is negative. The one way that you can check is using a cast rule. So my terminal arm is over here. So as you can see, only sine is going to be positive and the rest of the ratio is going to be negative. And it makes sense, sine is positive, cosine is negative, and tangent is also negative. So you can do the last step using a cast to figure out or confirm the sign of the ratio. Okay, so related angle, we actually call it a related acute angle. The reason why it's acute angle because it has to be less than 90 degrees. Now, related angle, in this case is represented as beta, is the angle between the terminal arm, in this case the green, of an angle alpha and the x-axis. Okay, so again, in simple term, what it means is that the related angle is always useful when you're looking for the ratio, but the location is always reference to the terminal arm to the x-axis. Okay, so this is related acute. Terminal arm to x-axis, that is related acute. Terminal arm to x-axis, this is related. And lastly, this is related acute. And you can represent it as capital RAA, that represents related acute angle. Now, so sine alpha, cosine, tangent alpha, it can give you the same ratio, but the opposite sign. Now, how do I know these opposite sign? Well, it all depends. Like I said, you can confirm using a cast rule, but the moral of the story is that you're going to get the same ratio. So let's do a practice question on finding the exact value. Now, like I said before, if they were to say exact value, I don't want to see any decimal. And most likely it's going to be involving a special triangle. So special angle that we talked about is 30 degrees, 45 degrees, and 60 degrees. In this case, because we're working with radian, it's going to be pi over 6, pi over 4, and pi over 3. So first, we have 5 pi over 4. So this is definitely greater than the denominator. So what I would do is, let's have an estimation of how big this angle is. So if I were to convert it, 5 pi over 4 using a conversion method of pi over 180, it's going to give me 225 degrees. So let's label where is 225. So 225 is definitely greater than 180, but less than 270. So it must be somewhere in quadrant 3. So this is 5 pi over 4. Now we need to figure out the related acute angle. Related acute angle is always the x-axis to the terminal arm. So this is my related acute angle, RAA. So how do I find related acute? Well, in this case, it looks like all we can do is 5 pi over 4 minus 180 degrees. So 5 pi over 4 minus 180, which is pi. And so the related acute angle, 5 pi over 4, pi, you could write it as 4 pi over 4 as the same denominator. Then you will get pi over 4. Okay, so as you can see, it's one of the special triangle. So in other words, it's going to be this, the equivalent expression is going to be sine pi over 4. Not done yet. The second step is you have to consider a cast rule. So because it's in terminal 3, quadrant 3, only tangent is going to be positive. So therefore, you have to put negative in front of the ratio. Why? Because only the tangent can be positive. So if I'm looking for sine in this quadrant, my answer is going to be negative. So go back to your special triangle. Sine pi over 4 is going to be 1 over square root 2, and then negative. But because we don't like square root in the denominator, we're going to rationalize it by multiplying square root 2 and square root 2 top and bottom. So your final answer is going to be negative square root 2 over 2. Okay. Next, we have cotangent 2 pi over 3. Now, cotangent is a reciprocal of tangent. So let me write a reminder. So cotangent of x is equal to 1 over tangent x. When you get a secondary or reciprocal of the primary trig ratio, your job is to first change it back into the primary ratio. Okay, so let's do a quick reminder. What's 2 pi over 3 in degrees? So you will notice that 2 pi over 3 is 120 degrees. Let's do a label. 120 degrees, it's in quadrant 2. Okay, this is 120. But we have to figure out the related acute angle. So related acute angle must be over here, from the x-axis to my terminal arm. RAA. So in this case, to find this angle, all you need to do is 180 minus 120. So 180 is pi minus 2 pi over 3. So when you subtract that, it's going to give you pi over 3. And that is my related acute angle. So I could rewrite this by saying cotangent is actually 1 over tangent 2 pi over 3. But we don't like 2 pi over 3. We can use a simplified equivalent expression, which is 1 over tangent pi over 3. And then we're not done yet. The second step is using a cast rule. So cast, C-A-S-T, only sine can be positive. So therefore, I have to put negative to my ratio. Now, using your special triangle for tangent pi over 3, Tangent pi over 3 is, so it's going to be 60 degrees, and it's going to be opposite over adjacent. So it's going to be negative 1 over opposite square root 3 over adjacent, which is 1. So 1 divided by square root 3 over 1, all you need to do is flip it. So minus 1 over square root 3, but we don't like radical in the denominator, so you can rationalize it to become 1 square root 3 over 3. And that is your final answer. Okay, so next type of question. Find the value of sine, cosine, and tangent function. So this is a special one because the points are on a Cartesian plane axis. So if that's the case, remember the unit circle. The unit circle has a radius of 1. So this one is going to be 1, 0, 0, 1. This is negative 1, 0, and this is 0, negative 1. The key idea is, if it's on a Cartesian plane, the x is always represented as a cosine ratio, and y is represented as sine ratio. And then to find the tangent, keep in mind tangent is equal to sine over cosine. Okay. So in this case, for letter A, sine of, let's say, theta is equal to, you have to look at 0. That is the ratio for sine. So it's going to be 0. Cosine theta is going to be the x value, which is 1. And tangent is going to be sine over cosine. So it's going to be 0 sine over cosine 1, which in turn, it means 0 for tangent. So next, letter B. Let's rewrite the formula. So x, if it's a unit circle, x represents the cosine, and the y represents the sine. So sine theta, in this case 90 degree, is going to be 1. Cosine theta, in this case 90 degree, is going to be 0. And then tangent is going to be sine over cosine. But 1 divided by any number, any 0 is going to be undefined. So tangent at 90 degree does not exist. So you can double check by putting it in your calculator. Sine 90 degree is going to give you 1. And you can also double check by putting in your calculator tangent 90 degree is going to give you math error, meaning it does not exist. Okay, so find the exact value. So this is a little bit different now because we're looking for an angle. So when we're looking for an angle, you always want to consider the numerical value. So always take the absolute value of the ratio to figure out the angle first. So absolute value of negative 1 is 1. So using your calculator, you're going to do x. So you move tangent to the other side. It becomes inverse. So tangent inverse of 1. And you're going to get 45 degrees. Okay. So 45 degrees is going to be pi over 4. Okay. Now, The second step is to consider that the ratio is negative. So then, using cast, now which quadrant would the tangent be negative? So it has to be quadrant 2 and quadrant 4. So these are the two only sections that will give you tangent with the negative 1. Okay, so therefore we're looking for this angle and this angle. Okay, so that is the related acute. So let's write down. So it can be quadrant 2. So there's going to be two answers, assuming that the domain is in between 0 and 2 pi. Okay. So if it's in quadrant 2, all you need to do is pi minus pi over 4, because this is my related acute, right? This over here and over here. So pi minus pi over 4. When you do the math, you're going to get 3 pi over 4. 3 pi over 4 actually means from initial arm to your terminal arm. That is 3 pi over 4. Next, let's look for quadrant 4. So quadrant 4, to look for it, then it's going to be 360 minus pi over 4. So 2 pi minus pi over 4. Make a same denominator, you're going to get 7 pi over 4. So what that means is that it's all the way up here to the terminal arm. That is 7 pi over 4. So when you're looking for it, the two angles that you have to pay attention to is pi and 2 pi. Why? Because the related angle is always referenced to the x-axis. So this will be the final answer, and this as well. So letter B. So we have cosecant equals negative 2 over square root 3. Again, we are going to take the inverse, the absolute value of negative 2 square root 3 to figure out the related acute. So x is equal to cosecant inverse 2 over square root 3. And then when you do it, you're going to get, depending on the calculator, you're going to get 60 degrees. Well, 60 degree or pi over 3. Now, so that is my related acute. Now, another thing, we know that cosecant is the reciprocal of 1 over sine. So when we're doing cast, we have to look at where is sine that will give me negative ratio. So sine in negative, it's going to be in quadrant 3 and quadrant 4. So let's do quadrant 3. So quadrant 3, again, so this is pi over 3. So to find the whole angle is going to be pi plus pi over 3. And that will give me 4 pi over 3. So that means from initial arm all the way up here to the terminal arm, this is my 4 pi over 3 angle. And that will give me negative 2 over 3. We are going to look for quadrant 4. So quadrant 4 involves 2 pi. So we got to do 2 pi minus my related acute, pi over 3. And that will give me 5 pi over 3. Okay. So therefore, from here all the way up to this point is going to give me the exact value of my x.